Good afternoon, class. In today's video, what I'd like to do is to go over an example problem from voltage. So in this one, what I'm going to do is I'm going to go over number 11 from the voltage review problems. So check that out if you want to follow along, and then we'll continue from there. So we've got K equals 8.99 times 10 to the ninth Newton meter squared per coulomb squared. We've got our Q, our charge of 3 coulombs, our distance we don't know, so that's why I left it as a question mark. And then our voltage is 156 joules per coulomb. So the question is, what is this distance R? And notice, I hope you're noticing that I'm picking all of the difficult questions to do an example from, because I want you to be able to handle those. The rest are pretty much a lot more algebraically simple. So, because it's like if I'm asking you to solve for V, I give you K, Q, and R, it should be fairly straightforward to complete all of those assignments, or all of those problems. But this one might be a little bit more challenging, and that's why I'm taking this one on myself. So in this one, we're going to use the V equals KQ over R, and so all I'm going to do is I'm going to take all of my numbers and plug them into the equation. So V is 156, K is 8.99 times 10 to the ninth, and Q is 3. Notice I'm using the shortcut method, so that's why you don't see any units right now. So all I've got right now is, so I've got that, and I've got this R in the denominator, which I don't like. I don't want R in the denominator. So to get it out of the denominator, I multiply both sides of the equation by R, because R over R equals 1. So now we've got 156R equals 8.99 times 10 to the ninth times 3. Notice I haven't done much. I haven't really changed everything that I could have. I do that because I want to make sure that if I can find ways to keep everything as a fraction or something like that and not have to convert to decimals and do approximations, I'd rather keep it as a fraction if at all possible. If I can't, I can't, but just to keep that in mind. So here we go. I've got, so now I'm going to divide both sides of the equation by 156, and what I notice is that 3 and 156 are actually divisible. They're actually factors of one another. So I said, okay, well that's great. It's going to be 8.99 times 10 to the ninth over 52, and that would be my answer. I would say, okay, that's wonderful. Except, here's the thing, I actually don't like a decimal in a fraction. That sounds, not nice to me. So what I did was I said, okay, I'm going to move the decimal over here 2 places. So in order to do that, that means now because I moved it to the right 2 places, I have to reduce the 10 to the exponent in the base 10 number by 2 as well, in order to make sure that everything is still, we're all on the same page. It's still the exact same number. So that's why I would get my answer of 899 divided by 52 times 10 to the 7th meters. And, is this okay as a fraction? In my class, the answer is absolutely. Of course, if you're taking a multiple choice test, this would probably not be one of the answers. It would probably be a decimal point that was rounded because it's going to be in proper scientific notation. If you're in maybe go on to another level and you have another, maybe you go and take a physics class in college, you may not, the professors might want you to do this in decimals. So that's okay. But for my class, it's okay if you leave it as a fraction, because that to me is a more complete answer than any decimal that you could write in scientific notation. So that concludes how to do a voltage problem number 11. Good luck in your studies. May the force be with you.